Hi students, in this video we will be focusing on the most important questions from each chapter exclusively for students preparing for engineering and NEET entrance examinations. We shall begin with the questions from electrostatics. Question number 1. A particle of mass m and charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is. Here you have 4 options here. You please read the question one more time. Now, as per the question, we have an electric field E, right? So electric field E is the positive charge, negative charge. In between we have an electric field E. Now what we are doing, we are placing a charge which is at rest initially. So initial kinetic energy is what? 0. Now definitely as it is placed in an electric field, this charge experiences a force, and you already know that equation. It experiences a force QE. The charge experiences a force QE. Now we already know this equation, right? Change in kinetic energy is equal to work done. You learned this equation in 11th standard. Change in kinetic energy means Kf minus Ki is equal to work done. What is work done? F into S or F dot S, right? Now Kf minus 0 is Kf is equal to, what is F? That is QE. And what is displacement here? As per the question, the displacement here is Y. So QEY, that is the final kinetic energy attained by the charge when it is placed in an electric field. So option B is the correct answer. The concentric spheres of radii capital R and small r have similar charges with equal surface densities. What is the electric potential at their common center? And these are the options. So we drew 2 spheres and we are supposed to find the potential at O, and we already know the total potential is equal to the algebraic sum of individual potential, right? Potential is a scalar quantity, so to get the total value you have to add it algebraically. Now the potential of smaller sphere is what? K q by small r, right? K is what? 1 by 4 pi epsilon 0 q by r. Q1 for the smaller sphere plus potential of the second one is what? 1 by 4 pi epsilon 0 q2 by capital R, as it is a bigger sphere. Now I'm taking 1 by 4 pi epsilon 0 outside. So q1 by r plus q2 by r, right? Now what is q1? For understanding that, you already know sigma. Sigma is q by area, right? So q, area is what? 4 pi r square. Sigma into 4 pi r square, right? 4 pi r square. For smaller sphere, it should be sigma into 4 pi small r square, and bigger sphere it should be sigma into 4 pi capital R square. Substitute these values here. Instead of q1 you can put sigma into 4 pi small r square by r, plus for bigger one you can put what? Sigma into 4 pi capital R square by r, right? Okay, now 4 pi you can cancel. Sigma is common, you can put it outside. Now r square and r square and r, you will get what? R plus r, right? So option B is the answer. A hollow cylinder has a charge q coulomb within it. If phi is the electric flux in unit of voltmeter associated with the curved surface B, the flux linked with the plane surface A in unit of voltmeter will be. And here these are the options. Here total flux through the cylinder will be flux through C, flux through B, and flux through A. That means phi C plus phi B plus phi A. Now we know as per Gauss theorem, total flux is Q by epsilon 0. And QC and QA, see they are symmetrically, the flux through them will be equal. So we can call it as phi dash plus phi B, as per the question is phi. So phi plus phi dash, this both are equal. So it should be phi dash will be equal to 2 phi dash will be equal to Q by epsilon 0 minus phi. And we are supposed to find the flux through a single plane, and that will be equal to what? 1 by 2 into Q by epsilon 0 minus phi. And the answer is option D. Two positive ions, each carrying a charge Q, are separated by a distance D. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be. Assume n electrons are missing from both charges, and we already know the force between two charges is equal to k q1 q2 by r square. What is k? K is 1 by 4 pi epsilon 0. q1 q2 means q into q, that is q square, by r. Here r is distance d, right? So d square. We already know q is what? Ne. Now F is equal to 1 pi 4 pi epsilon 0. Instead of q we can write Ne. So n square e square by d square, and we are supposed to find the total number of electrons, right? N. So equation will be what? 4 pi epsilon 0 F d square by e square root. So which option? See, option C. Two parallel metal plates having charges plus Q and minus Q face each other at a certain distance between them. If the plate are now dipped in kerosene oil tank, the electric field between the plate will, and these are the options. We already know that the electric field between two parallel plates carrying opposite charge is sigma by epsilon 0. Now when we dip the system into kerosene, the new electric field will be sigma by epsilon. Now if you take any medium and if you compare the permittivity, you must keep in mind that epsilon 0 is least. That means the permittivity is least for free space. That means when you dip in kerosene, this value increases. That means electric field decreases, denominator increases, and our quotient definitely decreases. That means EK will be lesser than the actual electric field. So decreases. So answer is D. A charge Q is placed at the center of the line joining two equal charges Q each. The system of the three charges will be in equilibrium if Q is equal to, and these are the options. For a system of charge to be in equilibrium, the net force acting on the individual charge must be 0. Now from the figure it is clear that the total force acting on the second charge is 0, because the force given by the first charge on the second is equal and opposite to the force given by third charge on the second charge. Right. Now to understand the equilibrium condition, you can either consider the third charge or first charge. For convenience, I am considering third charge. Force on the third charge. As per the question, it is in equilibrium. So total force on any charge must be 0, right? Now force on third charge is Q, right? Due to first charge, that is also Q, plus force on third charge due to second charge is 0, right? Now what is FQQ? That is K Q into Q, that is Q square, by 2A whole square plus K QQ by A square is equal to 0, right? Now so you can divide the whole equation with K, so K cancel. You can divide the whole equation with q, so q cancel. Now it become what? The equation become q by 4a square plus q by a square is equal to 0. Now see, q by 4a square is equal to q by a square. Now a square cancel, right? So small q is equal to minus q by 4, and option number C is the answer. Two identical thin rings, each of radius r meter, are coaxially placed at distance r meter apart. If q1 and q2 coulomb are respectively the charges uniformly spread on the two rings, the work done in moving a charge q from the center of one ring to that of the other is, and these are the options. We have two rings, ring 1 and ring 2. Both has radius r. The centers of these rings are separated by a distance capital R. Now the center of the first ring is at a distance BC, right, from the circumference of the second ring, and that will be root 2r. You will get by Pythagoras theorem. And the center of the second sphere is at a distance root 2r from the circumference of the first ring. Okay, now the total potential at the center of the first ring, that means potential at B, will be equal to potential due to the charge on the first ring. What is that? K q1 by r plus k q2 by the distance from the center of the first ring to the circumference of the second ring is what? Root 2r. Now potential at the center of the second ring is equal to, again it is due to two reasons: potential due to the charge on the first ring, and that is at a distance of root 2r, plus k q2 by r, right? Now what we are doing, we are moving a charge from one ring to another. Assume we are moving a charge from second ring to first ring. So you already know that there is an equation like this, right? W by Q is equal to change in potential difference, right? Or we can say V1 minus V2. On substituting, we will get the equation like this. Then W by Q is equal to, I'm taking K by R outside, then it become Q1 plus Q2 by root 2 minus Q1 by root 2 minus Q2. Rearranging, you will get like this: K by R into Q1 minus Q2 minus Q1 minus Q2 by root 2. Then it become like this: K by R into root 2 Q1 minus root 2 Q2 minus Q1 minus Q2 by root 2. As Q1 minus Q2 is common, I am taking it outside, so it should be like this. Now W is equal to K, I am substituting, it become 1 by 4 pi epsilon 0 R, then Q1 minus Q2, then root 2 minus 1, then all divided by root 2 into Q is the work done. Now we can check the options. See option number B, you can see same, right? Okay, so option number B is the answer. A hollow charged metal sphere has radius r. If the potential difference between its surface and a point at distance 3r from the center is V, then the electric field intensity at a distance 3r from the center is, and these are the options. As per the question, the potential difference between P and Q is V, right? Now what is VP? It is on the surface of the hollow sphere, right? That is K Q by small r minus potential at Q means it is at a distance 3r from the center of the hollow sphere. So it is KQ by 3r. So it become what? If you take KQ by r outside, it become 1 minus 1 by 3. So it become 2KQ by 3r, equation number 1. So this is V. We are supposed to find the electric field intensity at a distance 3r from the center, right? Okay, so this is V, and electric field E is equal to KQ by r square. Here what is r? 3r, right? 3r square. So it become KQ by 9r square. This is equation number 2. Now equation number 2 divided by 1, what you will get? E by V is equal to KQ by 9r square by 2KQ by 3r. So what will be the value? See, KQ cancel, then R will be cancel. So 3 will go up, right? 3 into 9 into 2. So E will be equal to V by 6. Okay, an R is here, right? R. So V by 6R. Electric field is equal to V by 6R. So it is option number A. A large circular ring has a uniform positive charge distribution, a negative charge on the axis, and close to the center is released from the rest. Released, not related. Released from the rest, the negative charge. And these are the options. The electric field at axial point of a ring of radius A is given by this equation. E is equal to KQX by x square plus a square whole raised to 3 by 2. Now, from the question it is clear that a large circular ring means radius is very big, right? Radius here is A is very big. And see, the charge is placed very close to the center. That means x is very small. So we are going to neglect the x in the denominator as A is comparatively bigger than x. E is equal to K Q x by A square whole raised to 3 by 2. That means A cube. Okay. Now we know that F is equal to, we are placing a negative charge, right? So minus Q into E. We already know F is equal to QE. As the charge is negative, I am putting minus here. So F is equal to minus Q into E is what? K Q x by A cube. So F is proportion to minus x. That means force is directly proportion to the negative of the displacement. Okay. So we already know that relation is there for simple harmonic motion, right? Simple harmonic motion. Force is proportion to x but in the opposite direction is a relation which is there for simple harmonic motion. Next question. See here, you are supposed to compare the electric field at A, B and C. And they have given the electric field lines, right? And you can see that at A and C, the distance, the spacing between the electric field lines are same. That means electric field at A and electric field at C is equal because this electric field lines represent the magnitude of electric field. If the spacing between the lines are same, then the strength is also same. Now, if you check at B, you can see that the spacing is comparatively more, which means electric field strength is comparatively less. Okay, so option C is the right answer. A charged particle Q is placed at the center O of the cube of length L. Another same charge Q is placed at a distance L from O. Then the electric flux through ABCD is, and these are the options. As per the question, we have two charges. One inside the cube and other outside the cube, right? Both are at same height, you can see, same distance from the face ABCD. The flux due to the charge inside the cube will be acting in the outward direction, and the flux due to the charge outside the cube will be acting in the inward direction of ABCD, right? That means the flux due to both charges will be equal because they are equidistant from that face, but the direction of the flux will be opposite. That means net flux through the face ABCD is 0. Next question. If the electric flux entering and leaving an enclosed surface respectively is phi1 and phi2, the electric charge inside the surface will be. As per the question, phi1 is the flux entering to the surface and phi2 is the flux leaving out. By convention, we already know the flux entering to the surface is taken as negative and the flux leaving out is taken as positive. So resultant flux will be the algebraic sum of these two, right? So it should be phi2 plus minus phi1, right? So it should be phi2 minus phi1. And you already know flux is equal to charge enclosed inside the surface by epsilon 0. So Q is equal to epsilon 0 into total flux. What is that? Phi2 minus phi1. So option number A is the right answer. Option number A is the right answer. A sheet of aluminum foil of negligible thickness is introduced between the plates of a capacitor. The capacitance of the capacitor, and these are the options. We already know the capacitance before inserting the aluminum foil will be epsilon 0 A by D. That is the basic equation for capacitance. Now after inserting the aluminum foil, the equation will become like this. C dash is equal to epsilon 0 A by D minus T plus T by K. Now we know that as aluminum is a metal, the dielectric constant K will be infinity. And as per the question, the thickness is negligible. So T will be almost tending to 0. So this part becomes 0 and T by K, T by infinity also becomes 0. So C dash become equal to epsilon 0 A by D, which is equal to C. That means it remains unchanged. A thin spherical conducting shell of radius R have a charge Q. Another charge Q is placed at the center of the shell. The electrostatic potential at a point P at a distance R by 2 from the center of the shell is, and these are the options. As per the question, we are supposed to find the potential at P. The potential at P is due to two reasons. One is the potential due to the charge Q at the center, and the second one is the potential due to the charge small q which is spread in the conducting shell. Okay, so the potential due to Q is K Q by R by 2. That we already know, right? Potential due to a point charge. So it becomes 2 KQ by R, and that is equal to 2Q by, what is K? 1 by 4 pi epsilon 0 R. Now potential due to Q. Potential due to Q means, see, potential due to the charge spread on the conducting shell will be always equal to KQ by R. that is 1 by 4 pi epsilon 0 Q by R. Remember that value will be same anywhere inside the conducting shell. Now you are supposed to find the total potential at P, right? That will be the sum of these two. So it should be 2Q by 4 pi epsilon 0 R plus Q by 4 pi epsilon 0 R. So that value is C, right? This is the value. Okay. Three charges minus Q1 plus Q2 and minus Q3 are placed as shown in the figure. The X component of the force on minus Q1 is proportional to, and these are the options. From the figure it is clear that there are two forces acting on minus Q1, one due to Q2 and other due to minus Q3. Okay, and see, you can see that Q2 is positive charge and minus Q1 is negative, right? And definitely this Q2 attract minus Q1, and we can call that force as F1. And you can see that it is acting along the x-axis, and that force will be K Q1 Q2 by B square. Now this Q3, right? Q3 is negative and Q1 is also negative, so they repel. So Q3 repel Q1 in this direction, right? We can call that F2. Now we can resolve F2 into vertical and horizontal component, right? Now this angle will be theta. So this will be F2 cos theta, and this will be the one along x-axis will be F2 sine theta. So the force on minus Q1 due to other two charges are F1 and F2 sine theta. So what is F2 sine theta? F2 sine theta is, F2 means what? K Q1 Q3 by A square, right? According to Coulomb's law. And sine theta, you can simply write sine theta there. Now total force is what? F1 plus F2 sine theta is the total force along x-axis, right? So it should be K Q1 Q2 by B square plus K Q1 Q3 by A square sine theta. So we can say force is proportion to, remove K, we are writing proportion, right? Q1 Q2 by B square plus Q1 Q3 by A square sine theta. So which option? Option B is the right answer. A charged ball B hangs from a silk thread S, which makes an angle theta with a large charged conducting sheet P as shown in the figure. The surface charge density sigma of the sheet is proportional to, and these are the options. As the charged ball is stationary, you have to keep in mind that the opposite forces acting on the charged ball will be equal. Okay, now we know that the gravitation force will be acting vertically downwards. Tension will be acting in this direction, right? Now I am resolving tension to vertical and horizontal components. This will be also theta because alternate angle, right? Now this will be T cos theta and this will be T sin theta. Now this charged ball of charge Q is placed in the electric field of this plate, right? So definitely it experiences a force, and that force will be QE, right? QE. So QE and T sin theta are acting opposite. They will be equal because the charged ball is stationary. T cos theta and mg will be equal because the same reason the ball is stationary. So all opposite forces must be equal. So we can write that T sin theta is equal to QE. And electric field produced by charged plate is what? You remember that it is sigma by epsilon 0. So that is equation number 1. and T cos theta is equal to mg. Equation number 2. Dividing 1 with 2, you will get tan theta is equal to sigma q by epsilon 0 mg. From that you will get sigma is proportion to tan theta, and that is answer number C. A thin metal plate P is inserted between the plate of a parallel plate capacitor of capacitance C in such a way that its edges touches the two plate. The capacitance now becomes, see, these are the options. Here the two plates of the capacitor is connected by a metallic wire, right? So definitely charge can flow from one plate to another. That means no separation between the plate. So D become 0, right? So C become what? Epsilon 0 A by 0, that is infinity. So option D is the answer.